Hi everybody, today we're going to take notes about different types of matter. So you can set your notes up like you see on the screen. We should have a target at the top in red pen, and we should have KCQ boxes drawn on the bottom. So we're going to look at different ways that you can classify matter. It's important that we can classify it into different categories so that we're able to talk about it during the year. There will be rules for how different types of matter behave, and so we have to be able to classify it into different categories. So the overall definition of matter is anything that takes up space and has mass. So things like your thoughts and feelings and ideas, while those are real, they don't take up any space and they don't have any mass, so we don't call them matter. Matter is a very big category, so it's very helpful to break it into smaller specific categories that would be much more useful to us. The first category we're going to look at is elements. An element is a pure substance. It's made up of one kind of atom. So for example, an atom of aluminum. You can have lots of the same atom next to each other, and as long as they're the same type and they're just sitting next to each other, we would call it an element. The big deal here is that each atom needs to have the same number of protons to be considered the same element. If an atom has 3 protons, for example, it would be an atom of lithium. If it had 4, it would be something different. If it had 2, it would be something different. As long as it has 3, it would be a lithium atom. So if we're looking at a pure element, it needs to make sure it has the same number of protons as the atoms next to it in order to be considered a pure element. The next category we're going to look at is molecules. Molecules are what we get when we bond more than one atom together. You can see some examples here. We have oxygen atoms bonded together, 2 of them. That makes the oxygen gas that we breathe. If you have 3 of them bonded together, it's something called ozone. You've probably heard of the ozone layer. Elements bond with each other when they share or they give away or accept electrons into their outer shell. This outer shell of electrons we call valence electrons. The outside ones are very important because those are the ones that make the bonds. There's lots and lots of ways you can draw molecules. You could draw them kind of as space-filling bubbles like this. You could draw them as like a little Bohr model. You could try to draw them so that you see the individual bonds. And you can have lots of different types of bonds. You can have single bonds, double bonds, like you see here in this oxygen, we got a double bond. Okay, you could have triple bonds. So there's lots of different molecules in the world, but the big deal that makes them all molecules is that they have atoms bonded to each other. An element, if we go back a slide, the atoms are just sitting next to each other. They're not actually bonded. A molecule has to be bonded. Here's another example. You can have a molecule that's really big and really complicated. Something like sugar has lots of different atoms together. If you notice, these little numbers down below are called subscripts. They're going to tell us how many atoms are stuck together in that molecule. So for example, this type of sugar called glucose, we have 6 carbons, 12 hydrogens, 6 oxygens. Big, complicated thing, still a molecule. A compound is a little bit different. Sometimes people mix up molecules and compounds, and we have a bad habit of using them interchangeably, but they don't actually mean the same thing. A compound is a little bit more specific than a molecule. A compound is when we have more than one different types of elements bonded together. So if you look at water, we have hydrogens and we have oxygens. So we know that it's a compound because we have two different types of elements present. We have hydrogens and we have oxygens. Here's a couple more examples. We have carbon dioxide. We have carbons and oxygens bonded together. We have table salt, sodium chloride. We have a sodium and a chlorine. You can have lots of different types of bonds in a compound, still single, double, and triple, but we can also have something called an ionic bond. The big deal here is that we have to have two different kinds of elements or more than two different kinds. You could have 3 or 4 or 5, etc. But you have to have at least two different types of elements. So let's do a little bit of comparing and contrasting here, okay? We have to realize that all compounds are also molecules, but not all molecules are compounds. This reminds me of in like geometry class when you learn about squares and rectangles, and I always get this backwards. All squares are rectangles, but not all rectangles are squares. A square is a more specific version. Just like here, compound is a more specific version. So if we look at our carbon dioxide on the left, it is a molecule and a compound. We have more than one atom bonded, so it's a molecule, and we have more than one type of element bonded, so it's also a compound. If you compare that to oxygen gas over here, it is a molecule. We have more than one atom bonded together, so it's a molecule, but it is not a compound. We only have oxygen atoms here. In order to be a compound, you need at least two types of elements, and we only have one type. We only have oxygen here. On the next slide, I'm going to put a little graphic that I think might help. This is what I was kind of referring to about the square and rectangle idea. So if you look, all compounds are inside the molecule circle, right? But not all molecules are going to be compounds. So I try to keep these terms separate. It is a little bit hard because if you start to look online and find extra practice or watch extra videos or things, people are really sloppy with this term. So just try to be careful, try to use the right one when it's appropriate. Next, we're going to look at a different type of matter called a mixture. We understand what mixture means from an everyday perspective. So let's look at it more from like an official definition and look at the different types of mixtures we can have. So in order to be a mixture, the big deal is that the things that are being mixed together are not chemically bonded to each other. They're just floating around next to each other. So for example, salt water. We don't have water chemically bonded to the salt. They're just floating around next to each other. There are lots and lots of types of mixtures. Sometimes we call them solutions. So Kool-Aid, salt water, the air that's in the room you are in, right? Air is a mixture. Brass is a type of metal. And same with 14 karat gold. Those are actually mixed with other types of metals. Soda is a mixture. Okay. Soda has sugar and water and flavorings and dyes. It has carbon dioxide gas mixed in. So you could have mixtures that are liquids You could have mixtures that are solids. You could have mixtures that are liquids and gases mixed together. Mixtures that are gases. You can have all different combinations of these things mixed together. There are two types of mixtures, kind of two big categories. Heterogeneous mixtures are ones that are not mixed very well. The classic example is oil and vinegar. You put them in the same container, but they're not going to mix perfectly. Some other examples that are kind of like everyday examples might be pizza, right? Every single bite of pizza is not identical. You have the cheese on one layer, you have sauce that's separate from the crust. You might have different toppings on different parts of the pizza. Cookie dough, maybe you have chocolate chips mixed in, but they're not necessarily perfectly mixed together. I can reach in and easily pick out those chocolate chips. They're not completely uniform. Italian dressing has like spices mixed in there. Dirt is always one that kind of gets people, but if you think about taking a scoop of dirt from outside, there might be a twig, maybe there's a leaf or a little rock, or maybe there's a bug or a worm in there somewhere, right? It's really not a perfect mixture. Homogeneous mixtures or homogeneous mixtures are ones that are perfectly mixed and are now totally uniform. If you were to take a scoop of it from one side of a container and a scoop from another part of the container, they would be completely the same. Air is homogeneous or homogeneous. If all the oxygen was in one corner of the room and all the nitrogen was in another corner of the room, that would not be a good situation, right? If suddenly there was no oxygen near you, that would be bad. Okay. So you can see there's lots of mixtures. Most things around us are mixtures. Tap water is one that gets people don't realize that tap water is not pure water. There are minerals, there's, fluoride, there's all sorts of stuff in that tap water. So it's not perfectly pure H2O. So it is a mixture, but because it's perfectly well mixed, it would be homogeneous. So just one kind of a summary slide that kind of goes through some of these examples. Oxygen atom would be a pure element. It's just an oxygen atom by itself. It's not bonded to anything. It's not a mixture. It's a pure element. If we have oxygen gas, we have two elements bonded together. They're the same type of element, so it's a molecule. The air that we breathe in the room is a mixture. We have lots of molecules, we have elements, we have compounds. They're all mixed together. It's not just oxygen. It's kind of a misconception of, how people talk in real life, that they sometimes refer to the air as oxygen. And oxygen is only one piece of what's in the air. I like this little flow chart. Let's pause the video and sketch this into your notes. I think it can be very helpful. You can sketch the big flow chart, and then maybe with your color annotations, you could go back through and add little notes about maybe what the definitions are, or maybe you could add little examples with your color annotations. That might be a great way to get some annotations on your paper. So you can see here the biggest, broadest category we have is matter. And I'm either going to be able to separate it into a pure substance or into a mixture. If it's a pure substance, we can either have elements or molecules. And if it's something very specific where we have lots of types of elements bonded, then we can come down here and finally call it a compound. This is about as specific as we can be. If it's a mixture, it's either going to be homogeneous, where it's well mixed, or it's going to be heterogeneous, where it's not very well mixed. All right, I hope that was helpful. Bye, everybody.